Data Transformation, Part 2. Aside from Magic ETL, Domo offers a variety of powerful ways to transform your data. In this lesson, we're going to tackle how to use SQL Transforms and Dataset Views. A SQL Dataflow lets you run custom SQL queries in Domo. Compared to the Magic ETL, it is a lot more technical, but it offers great depth of transformation capabilities. Let's create a SQL Dataflow for the customer and order dataset we used in the last lesson. To create a SQL Dataflow, navigate to the Data tab, click Transform Data, and select SQL Transforms. On the Dataflow creation screen, select the SQL type you want to use. For our Domo instance, we can choose between MySQL and Adrenaline. Other instances also have the option to select Redshift. Adrenaline Dataflows are an on-demand paid feature within Domo and typically require enablement by a Domo Customer Success Manager, Technical Consultant, or Account Executive. It is an in-house built high-scale and high-performance data transformation tool for massive datasets in Domo powered by the Adrenaline engine. It uses a SQL script-based transformation interface similar to MySQL Dataflows. They are optimized for datasets exceeding 500 million rows, where other methods like Magic ETL, MySQL, or Redshift Dataflows might struggle with performance or timeouts. For this lesson, we're going to use the MySQL Dataflow. The MySQL Dataflow runs transformations using the MySQL engine and supports the most standard MySQL syntax, so this is easy to learn for anyone who is already familiar with this type of scripting. This method works best for smaller to medium datasets as it is less optimized for large datasets. Back to our Dataflow creation screen, type in the Dataflow name, Maharashtra, product order, and customer details. Note that the name of the dataset and columns must not exceed 64 characters based on the limitations of the MySQL engine. Next, we need to select our inputs. Under Input Datasets, click Select Dataset and choose Order Details. Upon loading the first input, click Select Dataset again and select Customer's Order. Next, let's choose the columns to use for the data flow. Click the Order Details input. In the new window, navigate to the Select Columns tab. Remove the Quantity column by clicking its X button. You can also add individual columns back into the dataset by clicking Add Column and selecting the columns, or add all columns back into the dataset by clicking All. To view the data without the profit column, navigate to the Preview tab. Click Apply to close the window. After adding our inputs, we can now apply the transformations. Click Add Transform. We have two options here to create a table or SQL transform. A table transform creates a new table using a select statement and will always generate an output table. Due to an output table being generated, you can create easy indexes based on these tables. A SQL transform creates a table that typically doesn't include a select statement such as a stored procedure. This type of transform does not generate an output table. Select Table Transform since we need an output table for this process. We will name this transform Join by Order ID. In this transform dialog, we have the inputs and lists of transforms on the left. You can click on the drop-down to show the columns available or that input or transform. The center is the SQL field where you can type your script. The button below is the Run SQL menu, and on its far right is the Preview button. On the SQL field, type in the following. In this script, we've selected all columns from the customer order input and renamed the order ID of the order details column to details-order ID and selected amount from the details input as well. Then a left join is applied based on the order ID, and we've limited the records to customers living in Maharashtra. To see if it's working correctly, select Run SQL and click the Preview button. As we can see, the join was successful and the columns selected from both inputs are available. If there were any errors, it will be displayed in this menu as well. The Run SQL also has a drop-down for the Run to Here option. With Run to Here, you can choose to run the data flow only up to the selected transform. In the case of very large data flows with numerous transforms or outputs, this may help you save time when testing your data flow's code. Hit Apply to close the dialog. With the transformation applied, we can now output the data. Click Add Output Dataset. In this part, we just need to add a select script to get the data from the last transformation. Type in select space asterisk space from space open quotations join underscore by underscore order underscore ID close quotations. Name this output as Maharashtra product order and customer details. Click Run SQL to validate the output and hit Apply. With all that configured, we can now click Save and Run on the upper right to view our output. After running the data flow, we can now view the output on its dataset page. Another way of transforming data in Domo is via Dataset Views. It gives you a simple yet powerful way to reshape, filter, or combine data in a spreadsheet interface without having to build a transformed data flow. It is similar to a saved SQL view, which is a virtual table that references the physical one. Let's create a dataset view based on the output dataset, Maharashtra product order and customer details. There are two ways to access Views Explorer, from the dataset or within Analyzer. Let's use the former. In Domo, navigate to the Data Center tab, select the Maharashtra dataset, then click the Open with drop-down on the upper right. Select Views Explorer. The Views Explorer allows you to view all rows in the dataset or to sample a set number of rows to enable your changes to be seen more quickly without waiting for changes to display for every row. For this demo, we want to show the total order amount per customer for the customers located in Mumbai City, sorted in descending order. First, we're going to apply a group by and aggregation. Click the plus group button. In the Setup Group by window, drag customer name and place it under categories. Then add city under it. Next, drag the amount column and place it under aggregations. Click the aggregation type and change it to sum. Once done, hit Finish. After applying the group by, the preview should now aggregate the records to the columns based on our configuration. Next, we need to apply a filter. Click the plus filter button. Select the city column on the drop-down and tick the checkbox for Mumbai. Hit Apply to refresh the preview based on our changes. Finally, add a sort to our view. Click the plus sort button, then hit Add Sort. Select Sum Amount as the column to sort on and choose High-Low. Now we should have all our Mumbai customers sorted in descending order based on the total order amount. Save the view by clicking Save As and set the name to Mumbai Customers Order Amount. Upon saving, this will lead to the new dataset view that we can browse, create cards, and add analysis for.